The Dory is still top. Oh,
Bummer. Yeah, so again, I looked back through Canvas. Let me pause this real quick. Did I pause? So the special cases, I'm going to show you what they look like. We're going to knock out 6 examples. 2 of them are going to be graphing, 2 are going to be substitution, and 2 are going to be elimination. And I'll show you what a special case looks like here. Let's do this one. I'm going to do this a little differently than I did at third hour because it's, well, you don't need to know why. Here's our first equation. And then here's our second equation. Does anything about those seem fishy or special to you? There's another couple stupid equations, right? And for the 984th time, I have to, yes, you guessed it, get y by itself. And so what we're going to do is we're going to solve this system of equations by graphing the lines and seeing where they cross. So let's do the first one, the top one. What would we do first to get y by itself? I would subtract the 2x, giving me negative 2y equals what? Negative 2x plus 6, right? Because the 6 is still positive, we agree. So it's negative 2x, but the 6 just stays like it was before. And then what would we do? Divide everything by negative 2. And we are not doing inequalities today. We will go back to inequalities tomorrow, FYI. But for today, we just had to just take a little detour and fill in a gap here. So back to equations straight, just lines, no solid, no dotted, no shading, just lines. So the equation for this would be y equals what? X minus 3. Perfect execution. So if we play our cards right and all that basic skills stuff that we've been practicing all year is good, then we wind up with a very graphable y equals x minus 3. And I'm going to take that one and I'm going to put it up here. I like to clean house a little bit and say, okay, you're ready to graph. And now we're going to work with this second one. What would we do first?
You bring.
You could. I mean, honestly, some people really get bothered by the whole left-right reflection thing, Wyatt. So I'm with you on this one. But just to keep it simple for all the brains in the classroom, I'm going to take the 3y, move it over there. And I'm going to take the 3x and move it over there. Okay. This is just really good for very literal people who want their y on the left because I know exactly where you were going with it, Wyatt. But let's just do like this. So what do we get if we switch the y and the x?
Positive 4y
Equals
positive
3x minus 9. Algebra, again, I don't know when it clicked for everybody in this room, October, November. Algebra is really easy once you figure out that you're just throwing things over the equal sign and changing this. It's unbelievable. And then we divide everything by 3. And when we divide everything by 3, what do we get? Y equals x minus 3. Listen, it's at that point where if you're paying any attention at all, I mean, anyone that doesn't notice this, it's because you're daydreaming or not listening. They're the same line, right? And so we wouldn't, that's why I asked that at the beginning, like, does anything seem fishy about these equations? And most normal people wouldn't look at them and go, those are the same, right? We just go about our robotic business. We get y by itself, and then we realize, I'll be darned, they're the same. This is a very special case. This is a very special situation. And so if I'll color code these for us. We got a red one and we got a yellow one. So where would I start the red graph at? Down 3, perfectly spoken. And what is his slope? Oops, I meant to do red. Yep, so I'm going to go down 3, and then I'm just going to go up and right the same amount to make a perfect slope of 1, like this. or down and left to make a perfect slope of 1, like this. And then I'm going to grab a ruler and I'm going to graph the line. So, I mean, it's just what we've done before, but it would feel really weird if I said, okay, now let's graph the yellow line, because what would we do? Same exact thing. It's literally the exact same line. I would start at the same spot. My slope would be the same. And so if I graphed the other line, what I would realize is that the second line would actually sit right atop the first line like this. Funky, right? So, the solution to a system of equations is the point where the lines touch each other or cross. So what would we say about the solution to a system like this? It has infinite solutions. So we're just going to say that this has infinitely many solutions. Saying infinite solutions would be just as fine, FYI. If you understand the definition of a solution, then you understand that that makes perfect sense, because where the lines are crossing is quite literally consistent always. Never are they not crossing because they're the same thing. So that is example number 1 that I wanted to make sure you are aware of, is that if you see 2 lines and you're asked to graph them and they're exactly the same, really you only have to graph one of them, because in the end you know that the other one's just going to sit right on. So any questions about that example? Okay, let's take a look at the next one.
So I can somewhat.
For this one, I think I'm going to do the math. Oh, I've called an audible here, and I've decided that to save all of the algebra getting y by itself stuff, I'm just going to do it for us. And I can tell you when I look at this that on my first equation, I got y equals negative 2/3, bless you, of x plus 2. And when I'm sitting here looking at my next one, I see clearly that I got y equals negative 2/3 of x minus 4. So I just thought I'd save us 3 or 4 minutes of lesson time so you could have more homework time. If you're at all interested, if you're a very, very thorough math student, here, I'll just put these up here so you can see what they were. The first one, before I messed with it, was 2x equals negative 3y plus 6. And the second one was 24 equals negative 4x minus 6y. So if you'd like to go back at your own leisure and resolve those out, you're welcome if you want the extra practice. But I just thought I'd get us right to the important part. And those 2 equations at the top, do you notice anything about them? They have the same slope, which by definition means what? They're parallel, right? This ain't our first rodeo. We've talked about this before. And when 2 lines are parallel, it means that they cross where? Never. So let's do our due diligence and get these graphed real quick. So again, I'll just color code them. There's a red one and a yellow one. So where would I start my red graph at? Up to, and his slope has to go downhill. So we're just going to make sure we go down and right. Or up and left. Just make sure it goes downhill. And then the yellow line, where would I start my yellow journey at?
We go down.
Down 4. Good. Same slope, right?
Different.
Exactly, Brandon. Very good. So we can see that it's the exact opposite situation. Listen, bottom line is lines can do 3 things. If they're in the same plane, there are 3 things they can do. They can cross at some point, they can never cross, or they can sit right on top of each other. This is clearly the scenario in which they never cross. And so we would simply answer the question by saying that there is no solution. Okay. Do you have any questions on the graphing side of it? The first 4 questions on your worksheet are going to be graphing problems. Full spoiler alert. They're all like this. They're all either the same lines or parallel lines. What I want to look at with you for the rest of this lesson is what do these odd, I call it the funk zone. When I'm dealing with weird lines like that, I call it the funk zone. Well, I didn't know how to finish that thought. Let me just show you. I want you to see what it looks like when there's no graph involved. So like this. So we are for these first, bless you, we are for these first 2 problems very, very specifically going to use substitution.
Yes.
Okay. So we have 4 problems left in the lecture. 2 we will do by substitution, 2 we will do by elimination, because I want you to see how these situations present themselves from different methods. If Brandon's doing a problem by elimination and Cody's doing it by substitution, they still need to both be aware of what the situation is when they enter the funk zone. So would you mind pulling our door shut since there's sub across the hall and it's can't say it because I'm recording. So thank you very much, Bricklayer. So since we're doing substitution, which of the 4 variables would we get by itself? Bottom X, 100%. Any other answer would be just silly. So we're going to take the bottom X and we're going to get it by itself. And if we do that, it's going to say X equals what?
Yeah. No, sorry. Positive 3y
Mhm.
minus 2.
Perfect. And as you know, because I'm predictable, I'm going to put a box around this. And where are we going to put the contents of this box?
You're gonna put it
Where X is in the other equation, right?
so 2.
So we're going to put it right
2
there.
awkward void.
So we have -2
So
awkward void plus
awkward
6y equals 20.
6y equals 20. Then you put 3y
Huh?
minus 2.
Or because of the obviousness of the situation. Good. Okay, let's do our due diligence and let's distribute. What do we get?
Negative 6y
Plus 20.
plus 20 plus 6 equals 20.
And this is what I wanted you to experience. And yes, you can look back on this and realize there was a much simpler approach to take here, but I want to know that every one of you, under any circumstance, whether it's this class or the next class or the next class or the next class, that this can happen, what's about to happen. And it's not like I did something wrong. It's not like I have to call my teacher and say, hey, I think I messed up. This is not a mess up. This is a normal thing to happen. You realize now that when you combine your like terms, they cancel. And when things cancel, that they're gone. People sometimes say, should I put Y? And I go, no. Why would you do that for? That would mean there's 1 left. Like, that's stupid. A -6y and a +6y are gone, leaving us with this, a number, positive 20 on the left, an equal sign, and a number on the right. And our job is simply now to make like a second grader's assessment on these 2 numbers and ask ourselves, is 20 equal to 20?
Yeah.
It is. So this is a situation in which it turns out the 2 lines were actually the exact same thing, and this has infinite solutions. Were you making an observation about the original problem and the obviousness of these pairs of numbers? Or what are you going after there? No? Okay, just curious why you're skinning my problem, but I see what you're saying. Yes. So Brandon's filing a complaint over here, not entirely unjustified, that elimination would have been a great method for that system. I don't disagree, but this is the substitution portion of the notes. So I agree. If I were given that one on my own, I would have done elimination, FYI. Okay, let's do one more substitution. Any questions on that last one? Anyone want to guess what's going to happen on this one?
Probably the same thing. It's just different.
Please reserve your judgment for the fact that, yes, I agree, elimination would be more sensible, but I am a bossy britches and we are doing substitution. So take that. Which variable is the easiest to get by himself? Top y for sure. So what does y equal?
Y equals positive 2 minus 7.
Perfect.
Okay.
And then we're going to box that up. We're going to put that in place of y in the second equation. And that second equation is now going to say negative 4x plus 2 awkward void where y used to be equals 4. Quit your smirking. And what's going into that awkward void?
2x minus 7.
Correct. And as always, we just hope that we don't mess up. Like this job is just about impossible when we're making rinky dink, like forgetting that a negative times a positive is a negative. I mean, just garbage errors. So try not to make those. If we distribute, we get negative 4x, and then we get positive or plus 4x, and then we get negative or minus 14. And again, you predicted it that we're in the funk zone. We have entered the funk zone because through no fault of our own, the 4x and the minus 4x have eliminated each other. And again, we're left not with an algebra problem, we're left with a common sense problem. Does negative 14 equal 4?
Yes.
Negative 14
Oh,
does
sorry.
not equal 4.
Sorry.
And it's not like there's some x where we can make it happen. Like you can't solve it and fix it. These are two numbers that just straight up don't equal each other and never will. And for that reason, we would say no solution. So this would have been an example if we'd been graphing of two lines that were parallel. And hey, guess what? Now we get to do elimination. Any questions so far? A year of algebra is not complete if you leave my room having not been exposed to the funk zone of lines that have no solution, infinite solutions, and what it looks like algebraically when we're not graphing. So let's do two more, and then it's assignment time. Again, spoiler alert, no surprise. These are either going to be no solution or infinite solutions. So let's get to it.
I like substitution.
I like substitution too. I like it all. I don't really like graphing.
Yeah, graphing's not my favorite.
But we got to be good at it still.
Mm.
Well, if I put this up on the board or on a homework problem or on a test or something, and I said, which variable would you kill? Because we're doing elimination now, in case you missed that memo. Which variable obviously is easier to spot? The y's for sure. Everyone past fourth grade knows that 8 and 5 both go into 40. Not everybody knows that 20 and 32 both go into 160. And so we're within our rights to assume that you all would spot the 5 and the 8 and say, I got this, right? So what we're going to do is we're going to take the top equation and we're going to multiply it by negative 8 and the bottom equation by positive 5. And you had to do a negative because the signs were plus plus, and we don't like plus plus. Plus plus doesn't cancel. And so here we go. Let's math. If we distribute across, I hear the unsheathing of a calculator. It's appreciated. Very good. So here we go. What do we get? Huh? We get 160 x's. And that's not interesting to me because that's not what I came to do. What I came to do is this next one. What's negative 8 times 5? Why?
Negative 40.
Yeah, that was on purpose. We wanted that to happen. And then equals what's negative 8 times 7? Negative 56. And again, this y part on the bottom is not interesting to me. Like I don't really care. I still need to know. But what's 5 times negative 32?
Negative 160.
Negative 160.
Oh, yeah.
Okay. And it may not even occur to you there that we're in the funk zone. Because listen, we did not set out to make that be the opposite of the one above it. That was just a bonus, right? What we did set out to do was what happens next. What's 5 times 8y?
40.
Yeah, that was on purpose. And then 5 times 0 is, of
Mhm.
course, 0. So we have a system now where we're ready to draw our line. What we did on purpose is what I'm about to cross out. That's what we set out to do. And along for the ride came the X's, and we realized, hey, bonus. I also got the X's to cancel. Now, imagine if I wrote an equation that looked like this. Everyone would complain. So we know in a case like this, we have to put 0. Normally, I tell you, don't put zeros when things cancel out. Just don't. Just cancel them out. But in this case, you can't leave an equation empty. 0 represents emptiness, and we use it to hold a place. And again, I ask you, is this true or false?
False.
Of course it's false. 0 doesn't equal negative 56. So which situation is this?
That's no
This is
solution.
no solution. These lines, if we graph them, would be parallel. You know exactly where I'm going, but let's finish it and make it official. So example number 6 is one more elimination. So again, please do not assume that you did something wrong when the variables disappear. It happens. And when it does, it means something, not that you messed up. It means something bigger and better than that. All right. Last one. All right. So I say this again because I play averages. Some kids know 6 and 15. Everybody knows 5 and 2. So we would probably pick the Y's, right?
Yeah.
I'd say 80% of kids would know that the 15 and the 6 could go into 30, but I would say 100% of kids would know that 2 and 5 both go into 10. So let's play the safe route. So the good news this time is I don't have to multiply by a negative because check out these signs. They're already opposited. So we're going to multiply the top equation by 2 and the bottom equation times 5.
Okay.
Right. So again, help me with my math. I struggle with multiplication. So as we distribute through the top, what do we get? 30 X's. I like that. I like that. Equals.
Thank you.
I like that. Yep. Yep. I mean, you're so good at this that you can almost like send text messages and talk to your friend on the phone and probably make yourself a sandwich while you're doing it because it's just like cruise control by now. And so you're not really maybe even noticing these things are happening as you go. But then you look up and you realize, okay, good, I got my Y's to cancel. And then you go, bonus. I also accidentally got my X's to cancel. And remember that when everything cancels, I have to fill it with a 0. And then I just got to do some little kitty math. What's 20 plus negative 20? I hope so. I've been doing it wrong for a long time. And does 0 equal 0?
Yes.
It does. What does that mean? It means they
Okay.
were the same line from the beginning. We just maybe didn't notice it. So this one has infinite solutions. So do you have any questions about that? All right. So I'm going to hand out assignment number 37. And we're going to work on that. I'll keep the recording alive.